Okay, so the population of foxes on the outskirts of a city is starting to increase. It's given to us with this, where N is the number of foxes and T is the years after the observation begins. How many foxes were initially present? So now you'll finally get to see what I mean in the other questions about the initial problem. So A, so N, start that again. A, N, T, or N of 0 is going to be equal to 480 minus 320 e to the power of negative 0.3, and we're substituting 0 in to find the initial population. So when T is equal to 0, that is the first year of the fox population. Now, when I chuck that value in there, we should get this part here will become 1. So 320 times 1 will just make 320. So we're left with 480 minus 320. Meaning that our initial fox population is going to be 160. So initially, when T equals 0, we have 160 foxes living their best life. By how many had the population of foxes grown at the end of the first year of observations? So if it's the end of your first year, that means you're starting your second year. So your second year will occur when T is equal to 1. Now, we won't be finished when we just chuck that straight into our answer. We need to make sure that we do, because we want to know the increase. So it'll be this one minus that one will get us the increase. So let's do that now. Go over to our trusty dusty calculator, punch that bad boy in. Okay, so we have 242.94. Now, it doesn't make sense for us to have part of a fox. I'm not having this argument again about what happens if I cut off half of my arm. You're still a person if you're missing limbs. Okay, so 243 foxes by the end of the first year, meaning that the increase will be given by T1 minus TO. I should say NT1 minus NTO. So 243 minus 160 is going to give me 83. So we have increased the population by 83 foxes. Now, I'd like to see this in full sentences in your book, not like the scrappy-rappy thing that I'm doing here. After how many months does the model predict that the number of foxes will double its initial population? So, if this was my initial population, we want to know at what time will the model be equal to 320? Now, where did I get 320? I times our initial value by 2, which gets me this. Happy days. So 320 is equal to 480 minus 320e minus 0.3t. So we're solving for the time. When will this happen? So take this one across first. That will give me negative 160 is equal to negative 320. Pretend like that turned out the way I wanted it to. Take this to the other side by dividing it. And that will give me 1 over 2, or a half, is equal to e to the power of negative 0.3t. If I take this across, then that will become ln, natural log or log with base e, a half, is equal to negative 0.3t. And then I'll take this one across by dividing by negative 0.3. So let's put that in our calculator and work out a time. So ln 0.5 divided by ln 0.5 divided by negative 0.3. So The time will be 2 years or 2.3 years. Now, if I wanted to convert this to months, it's not asking me to do that, but sometimes it does. So if I wanted to convert it to months, I would take that 0.3, so 2 full years, 0.3 of a year. Now, there's 12 months in a year, which means 4 months. Okay. Sketch the graph. I'm not going to do that with you guys now. Explain why this model does not predict that the population of foxes will grow to 600. If we sketch this thing, you'll very quickly see that an asymptote is at play. Now, our asymptote is this number here, meaning that it'll get close to, but never touching 480. So if I had sketched it, you would have seen if this is my asymptote at y equals 480, and then I've got down here my initial population is 160. So my graph would look, like this. It would look something like that. You would never touch anything above 480, which makes sense for populations because maybe your foxes really love snacks and there's not enough snacks to go around. So then some of them are super hungry and then they die. What a weird way to end this video.